All right, here is the site bioinformatics.org, as you can see here. And we've been here once before in class. And what you do, go over here to the side and look for something called SMS2 right here. All right here. And sequence manipulation site. And you get this, and over here on the left is a long list of basic bioinformatics programs. The one we want today, it's going to help us find or figure out what a terminator looks like. But I want to put a terminator on the end of a non-gene so that nothing else will interfere and we can clearly see what a terminator looks like. So what I'm going to do down here is I'm going to go down to sequence figures. Let's see, no. Let's see, it's mutate DNA. No. Let's see, where is it? We want to create a random sequence. So we're looking for random sequence, mutate, random DNA sequence. Okay, right here. So we're going to click on that. And so sequence manipulation suite, random DNA sequence. And it's 1,000 bases. That's fine. We just want to create one of them. And so I'm going to submit. And we're going to get a little FASTA here. And I'm going to cut and paste this. So I grab that and Control C. And then I'm going to open, instead of opening my program or whatever to do this or whatever, we're going to open up just a regular Notepad program. The one I recommended that you download is Notepad++. You can use regular Notepad. Don't use WordPad or Word. It'll add things to it. But Notepad would be fine. And you can also search with Notepad. I think it's better with Notepad++ here. So let me open Notepad++, which you can download. In Linux, it's called Notepad QQ, but it's the same thing. All right, so here's what it looks like. And let me close out all of these sequences. Here we can get rid of all of these. I have them. It's smart. It saved what I was doing, even when I closed it. All right. So now I'm going to go to here. This is just called New 3. There's nothing in it. I'm going to go Control V. Now it's a random sequence consisting of 1,000 bases, but we have a problem because we want it to be capitals to be a real FASTA. It said it was making us a FASTA, but it made it small letters, so it's not really. Not many programs would read this. So we have to take this and we're going to have to replace, and that's one reason I'm using Notepad++, because it's pretty good at replacing things. So I can go down here and hit replace, and what I can do is I can replace all the little A's with big A's, like this. All right, and replace all. Oh, yeah, okay. Okay, so yeah, that worked, including in the beginning. That's fine. In the first line where we give our description, I don't care. Now we do C's, so we capital C. Oh, no, it's going to be little c replaced with big C, and replace all. All right, and of course we're going to do G, little g replaced with big G, replace all. All right, and little t, and replace it with big T, replace all. All right, so we now have a legitimate FASTA sequence. Now what I want to do here is I want to add a terminator near the end. I don't want to put it at the end exactly. This is 1,000 letters. Oh, and so let's make it, let's just add a line like this, and we're going to put in exactly the amount needed to make this look good. And what we're going to do is we're going to make it the most basic terminator that we can have. And we're going to make a whole bunch of A's. maybe not that many. And then some CGs. Oops, CG. All right, and then a whole bunch of T's. Okay, and we're just gonna, let's see, a few more A's than T's. Let's go ahead and reduce this by about 3, and let's put 3 more A's in there. Or maybe, that looks about right. Or about even amounts with some C's and G's in between. Maybe, let's make it a little more. Let me take out 2 T's and 2 A's. And let's add some more C's and G's in there. There we go. Alright, so I've added essentially something that would make a terminator. Now, you will never get this sequence. You will get a side where it's maybe 65-70% A and 65 and 70% T, and but the C's and G's will be higher. It'll probably be like 80-85% C's and G's in this part. But usually this is a bit, the AT part is more rigid, the stem, and then the loop part is going to be more flexible. But the idea is this is the general one. This is a perfect one. You'll never see this. But it's going to stand out because it's very close. I'm pretty sure I got close to the same number of T's and A's. That was the idea. Probably still looks like there are probably a few more A's, but it's close. So this is going to show us what a terminator looks like. And if you don't remember, we'll review this in class, but it's basically I was telling you that when DNA is single-stranded and it's been unzipped, this piece would be like a sheet in the wind or a flag in the wind, and it's going to be relatively flexible, and it's basically the A part is going to be able to touch the T part when it's single-stranded, and they're going to bind as if they're double-stranded DNA. I mean, they will be double-stranded. They will just end in single-stranded DNA sequences, and at the top, the G's and C's, which are a little bit more flexible, the region that has more G's and C's in it will be flexible and be able to make the loop. So this is a general idea behind a hairpin loop. You'll never see this one. It'll be, it won't be all A's, it won't be all T's, it'll be mixed up. But let's go ahead and see. We're going to save this. And I'm going to save this as, let's see, where are we going to save this? We will put it on desktop. Alright, and I have something here, Spring 25. There, I'll just save it in here. And we will save this as hairpin example, or how about terminator example? Something like that. .fasta. Alright, now I'm going to save that. We know where that is, and I can close this now. And what we need to do is I'm going to go and open up Eugene to do a dot plot. And we're going to see, since this is a random sequence, we shouldn't get a lot of mess around it. Let's skip those updates. I'm going to go Tools, and I'm going to go Build Dot Plot, and I'm going to find this sequence. Alright, nope, it's up here, and I'm going to open that, and what I'm going to do here is I'm going to compare it against itself. That's what I'm going to do first. And so we're comparing this sequence against itself, and this is what you do when you want to find a terminator. You will compare your sequence against itself, and we'll go next. Alright, now we want to make for sure that we click on inverted repeats. Alright, and we need to do this, 5. We might be changing that. We also might be changing this. It depends on what we find. So these are our two variables that we will be looking at with our sequence, and so you could take your sequence, and to find a terminator you would compare it against itself, and let's go see what we find. Aha! Now, if you look down here, what did we find? We found this really strange piece. Everything else is kind of random, all right, and we found this piece down here. Now, of course, this is way more than it's more. It stands out more than it should. Uh, but you can see that that sequence we put created a really interesting figure down here. So let's kind of zoom in on this. I thought it would zoom in the way I want. Come on. Nope. I'm not getting it to zoom in. Why is it not zooming in? Well, we're going to have to look at it like this. I made too large of a sequence. My controls just aren't working right. Okay, well, we'll look at it from here. But you can see, all right, that we've come up with a figure very similar, kind of like this these blocks. Well, the blocks are there because it's all the same sequence. But you can see it definitely shows up. We see an interesting thing down here. I'm going to, didn't mean to do that. I'm going to increase this so that it's not quite so rigid. Let's make it, let's see what happens when we make this 10 instead of 5. All right, and go. Okay, of course we get rid of everything now. And let's go and let's change it now. And let's also, well, let's reduce this. If we're going to do that, let's reduce this, see if we can get some things. Let's go to 70%. This will probably make the whole thing black, but let's see what we get. Nope, nope, it doesn't. All right, we still get this. This is a little too busy, so that was too much. Let's make this 90%. All right, that's back to something like this. Let's see what else we can do. Let's reduce this to 2. Go lower. What do we get? We still get this. That's an interesting pattern, isn't it? All right. Maybe the computer was right on this one, and that was the right amount to do it. I'm going to go 7 and 70. Still too much. I'm going to go to 100% again. And yeah, okay. Well, you can see that we're getting this piece like this, and that's not what you're going to get, because you're not going to get yours isn't going to be perfect like this one. But if it were perfect, but if you were to reduce, shall we say, the size of these so that it's more it's a little less faded, what you're going to get is you're going to get a some lines near the center, all right, that are going to be both following this, so like this, they're parallel, so you're going to get a bunch of lines that are parallel, but you're also going to get lines that are perpendicular to the lines, so like this one and like this one. You're going to get a lot of them, and they're going to look like T's or pluses, and they're going to be fairly near, about the same, well, definitely the same distance we have here. And you're going to see these pluses or X's or T's, whichever way you want to, T's, X's. So here, this one would be similar, but if you put a parallel line, a little one like this at the end of it, like a T, or maybe in the middle of it, like a cross, that would be more of an indication of a hairpin loop. All right, so in other words, you would, so let's see. You can certainly see that you get it. You're just getting a lot of T's and pluses, and, or whatever you want to call them. So there are no T's and pluses anywhere else on here, because this is a random sequence. So here we get some that are parallel, but you don't get a cross. You don't get something. You don't get another sequence moving across it. So if you'd take this one and moved it closer to here, that would be more of a kind of a indication of a hairpin loop. If you'd moved this one down and these two touched, or even crossed a little, that would be a hairpin loop. That would be the indication of a hairpin loop. But you need them to be parallel. You need them to be on either side, just like these are. So what we're seeing here is a whole bunch of these T's or crosses across from each other. But this is essentially what you would look for. You would look for some lines, T's and crosses across several of these, like this kind of hex here. So let's, one thing we can do, we can go alter our sequence, and maybe we can get it to look more like a natural one, so I can show you. So I'm going to close out here. All right, and we're going to go back to our sequence that we were just looking at. I'm going to open Notepad++ again, and here we are. And what I'm going to do is I'm going to go along, and every now and then I'm going to change it and make, let's make this an A. So we'll keep it mainly A's and T's over here. And let's put an A here. Over here, let's also put some T's. Alright, and let's just randomly put a C and a G here somewhere. Let's do the same over here. I'm going to put a C and a G. Alright, so that's not quite the same. And then in here, oh, let's go ahead and put an A here, and let's put a T here. So we've added a little bit of variation so that it's not 100%. And we'll save this and we'll run it again. And we'll see what it looks like. Alright, so we're going to go to Tools. We're going to build dot plot. We're going to go find our fast day again after I've changed it. We're going to compare it against itself. We can go next. We'll go ahead and use their recommendation, and we'll do 100%. And oh, search for inverted repeats. Don't forget that. You have to do that to get this work. There we go. All right. Not so much T's. We do get some lines out there. All right. You get some parallel lines here. Let's see if we can zoom in a little. Here we go. See these little crosses right there? That's what we're looking for. All right. You're looking for something like that. You're looking for some lines that cross both ways, and we get that here. So this would be a very good, this would be like, oh, absolutely, that's a hairpin loop. We've got a couple of T's or crosses, whatever we want to call them. Right there, when I zoomed in, you could see them. All right, so that's kind of what we are looking for. Let me do that. This would be about as good as you would ever see to get like tic-tac-toe signs. You're not going to get tic-tac-toe signs. You're going to get T's, or you're going to get crosses or X's, whichever way you want. All right, so that's kind of the idea of how to find a hairpin loop. You would look for something along those lines. You might also see some straight lines, parallel, perpendicular lines moving out away from them. So you can see here you've got some lines moving out. But if these cross these or T them, yeah, good indication of a hairpin loop. Now a T going in this way is not. This one needs to be out here. All right, it needs to be out here, not next to it. See how this is a T, but it's going the wrong direction. You need a T that goes here. It could be the other way. The line could be on this one, could cross it in the middle, could cross out here. Usually it's going to cross out here. The way we did it, it crossed pretty much through the middle. And it's kind of like they're on top of each other. Here you see some that are kind of out here. You see that. Now the thing is, are they over here? Yes, they're over here. So that's a good indication. So these tic-tac-toe ones and then these regular ones here, this is what I was talking about, T's. All right. And you want that. That's what you want to find. You can see there something's way out here, but that's way too far out. All right, let's change the parameters here. Let's increase this to 10. All right, and let's go down to 90% and see what we get. Now we get just straight lines. All right, but they're the only straight lines on here. All right, so you can see here. So that was a little too much to find your terminator, though a straight line, and that's the only straight line across there, that's a good indication to, hey, maybe we lower the lower it. So I'm going to go down to 4, and let's see what we get. Yeah, much better. All right, so smaller sequences are better with terminators. All right, so that's something to keep in mind. See, we get lots of these little crosses now when we do that. And we reduced it to 90% as well. So 90, I only had to get 90%. So let's increase it. Let's go back up and let's do like 8, but let's lower this to like 70%. So we're making the length longer, but we're reducing the number of. So let's see what we get. There we go. Now that looks more like what you might find. All right, so you can see it's looking more like that first one we saw. This is probably the best you could ever hope for. Probably not even close to this. Probably more to like that checkerboard is probably the best you'll ever see. Maybe I've seen one this good once. So I'm trying to make one that doesn't look so good. Let's see. Let's go back up to 10, but with 70%. Still too good. So let's go parameters and let's increase this to 80%. Okay, let's look at this. If we look at this one, they're very close to the center line for the crosses. That's about, you probably wouldn't see it. It's going to be further away than that normally. So we've probably done what? We've probably gotten too long to make it, to get the crosses like we want. So let's go back to 7 and see if those crosses come back. Yes, they do, right here. So length is the one that you have to keep kind of low on the when looking for terminators. So let's go to 6, and I will drop this to 50%. Now this is going to be a mess. You'll see what I mean. Yeah, don't do that. That is what you don't want to do. So you have to keep this one up reasonably high. All right, so back to, let's try 60 and see what happens. We reduce it. All right, we reduce the interference or whatever we want to call it. Then we go to 70. We reduce it. We've still got crosses near the center. We go up to 80%. Okay, still got it. All right, and then we go to 90%, and then it disappears. All right, so let's go back to 70. All right, and we've got them nearby. And let's now increase this to 7. All right, that kind of made it worse. Let's go to 8 and see what it looks like. Yeah, we're still getting the checkerboard kind of thing near the center. Not quite what I wanted. Let's go to 9. Alright, so let's go back down and let's do 5. So I'm going to go the other way. Alright, and then I'm going to increase this to 80%. Alright. Increase this. I'm just going to go to 100. Actually, 100% is the good one here. So try to keep. I would suggest try to keep this high and go lower with this one. Let's see what happens if I go all the way to 3 with 100%. Well, it gets a little busy. You do see more down here, but you'll get busy stuff. This is a random sequence, which means you've minimized the amount of stuff out here that's going to match. And you can see we've still got a lot matching, and this is on a random sequence. So you're going to get it'll be much busier if you're comparing a regular gene. All right, but you definitely get your patterns that you want, the T's crossing one another or the X's. If it looks like the best number for this is 6 or 5 at about 80%. Was that it? No, that was too much. I forgot what we... Oh, that's too much. Okay, yeah, at 100% actually. No, not 5. Must have been 6 or 7. So for this one, that's too much. I've forgotten what we did to find a good one. So 70 at 80%. One where we got that. Oh, here, this would be the best. Okay, this is showing a cross. It's not too much, not too little, but you've got crosses here. You've got one going all across this thing that kind of touches as a T, and then you've got another one going through that over to the side. Yes, this is the best one here. So this would be the best indicator of a hairpin loop, and the reason is because of, let me see, I think, oh, I'm just going to click on something out here. Yeah, there we go. Now I'm going to zoom in. Let me close this. Oh, no, don't want to do that. Oh, I did it anyhow. Okay, that was it. That's how you find a hairpin loop. It takes some maneuvering of your dot plot, but you can see little crosses and little T's, and if you see a couple of them, if you see one, that's enough, but you probably want to see a couple of them. Let's see if we can go and look at a real gene and see if we can find one, and then that'll be the end of this video. So I'm going to go back here. I'm going to go and look for, I'm going to do a new dot plot, and this time I'm going to look for an actual gene, and we'll use one of them we've been using, which is let's use this long one, the two genes GPX1 and RHOA on it, and we'll see if we can find, there should be 2 terminators there if they're there. Not all terminators form hairpin loops. There is a subset that are just a sequence with a protein binding. But for the sake of this class, I wanted to show you something. We see lots of things with proteins binding to a sequence, but finding a terminator is a different, finding a hairpin loop and some folding, that's more interesting, and we needed to see the variety. So I gave you one here that was a hairpin. And hairpin is the more common one. Alright, so we're going to make sure you click on inverted repeats or this won't work. Compare it against itself, inverted repeats. And we'll just start with the suggested here. And we will look, we know around 6,000 to 7,000 there probably should be a terminator in GPX1 on this sequence. So we know that it should be down in here, so between 6 and 7,000, somewhere in here there should be a terminator. Now we're going to have to zoom into that. So maybe one of these 2 pieces. Let's look here. It could be this one. Oh, you can also look at the sequence down here if you zoom in, and you can hit. Oh, that's the wrong way. There we go. And actually the sequence that you're looking at will show up as letters down there. Yeah, this is okay. So this is about 6,000. This might be it. Let's see if we can see anything. Well, it's too solid, so we need to switch it a little. This may not be it at all. Just so let's go back. We were trying for 5 before. This looks more. So smaller sequences typically. All right, now we will go and reduce this a little. We'll go to 80. Way too much, but hey, that region we were looking at, well, this is in the, yeah, this region we were looking at, it has a lot of low complexity in it. I see a cross though right here, but that's a mess. We need to do something about all this. So let's increase this to 8. Okay, well, we're back to, where's our 6,000? Right here. We don't see any, well, I guess it's probably this piece that we were looking at. Let's zoom in again. Get over there. Is there, I want to scroll this, but kind of changed up the way this works. Scroll. Let me do something down there and then zoom in on that. Well, we got away from our there should be this box I can control it with, but if I close this, it closes everything apparently. I want this box to go away. Let's see if I can make that box go away. No, I can clear it, which is not what I wanted. There, this one. So see this box? This is what I want. I can move this, all right, and go to the piece I want. I want to go down here, of course, at the end. All right, and right here, maybe a little bit further away. So 6,000, I want to get 6,000 in the middle. There we go. So you might have to click. It looks like if you want to do this, the one with the hourglass here is the one you click to get the box centered. Okay, so now we can home in on our 6,000 sequence that we're looking at, and we can begin changing. So here, no, I don't see it as a terminator. The terminator could be what we want here. We want this up here. If this were up here and we got some T's, or this one was over here, or some X's, we would say it's a terminator. So we are here. I'm going to go and change my parameters again. We're at 8, so we want smaller, so I'm going to go 7. Like I said, I knew that would make a mess. Are we getting that? Not in this region. Still, this is too convoluted. Let's go ahead and require 100. And zoom in again. So let's shrink it some more. Back to 6. No, still that needs to be on top of that for us to be confident. Let's see. Make it 80%. Getting better maybe. But that might not be the terminator. That's the other thing. Let's see. So we did 80. Let's go 5. where we started, but 100%. Let's increase this back to 100. No, I am not convinced that that is a terminator. This doesn't look right. Alright, so let's go. And let's look at just the end. There we go. So we're going to go down to this. That was a 6,000 area we were looking at. So let's go down here and look at this one. Alright, and we're going to zoom in here. Maybe this one is the one we're looking for. Here's some that maybe, no. I'm just looking around here. It may not be at a cluster like this. I don't remember ever doing this one. That's kind of funny, because this one I look at a lot, but I don't remember where the terminator is. Alright, let's increase the size to 7. Alright. Wow. Very similar. The size to 10. Alright, now let's slowly lower this. Let's go down to 90. And then we go down to 80. Oh, look, here crosses up here. That very well may be it. Let's zoom out a little. Look along here. You really want them a little further away from the center, but that would look better than what we've got going on here. And of course, you're speculating. You don't know that this is where the terminator is. The best you can do. Here's a little cross out here, a little far away, but it's on both sides. Here you've got one in the middle. You know, that could be a terminator. And here's a low. It's in the right spot. Alright, let's see. Let's reduce this now to 8. Hopefully it doesn't make it too busy. Oh no, it went the other way. But we lost our view of this over here. This just may be a lot of letters of the same sequence. But you would expect at the end of this gene, which is at 6 or 7,000, between 6 and 7,000, you expect a terminator, and you can look for some little crosses there. Yeah, at this point, I would say you're turning in this assignment. Those crosses there that we just had would be sufficient for you to say, well, that's the potential terminator. Let's see if I can go to 7 and see what we get. And see what we see in this region. I see some things that are close over here. Don't quite cross each other. Oh, we're in the 6. We're still 2. I need to go down further. Where's the diagonal? Oh, I'm way off. Here we go. Around 7,000. Somewhere in here. Alright, that's pretty good. Right in here. Yeah, I get some crosses up here. Yeah. I would choose that piece. See the little crosses all around here? Alright, little crosses. not quite crosses down here. Yeah. Let's lower this one more. Get some here, get some up here. Get a lot of them in here, actually. Yeah, this might be a really complex loop. Oh yeah, I see them after this. I was looking at this darker piece, but that darker piece is just probably a long stretch of like T's or something, or A's. And the hairpin loop, though, is looks to be around here somewhere. You could find something in this for sure. But of course, we don't know for sure. I'm going to go down to 5, but I'm going to go back up. I'm going to go back up to 100 and see what we see here. If you see something at 100%, it's probably it. See, we lose most of them at 100%, but we do get them crossing here. It's not like a T, it's more like just an angle. But I would say there is something right here, maybe. All right, and here's a T, a little far away, but oh, it's not on the other side. You need it to be on both sides. Here, here. This is on both sides, and they do cross. Here it's sort of, but it's right at the line. That's probably not it. So probably this one here, right here, is the best choice on this, just this piece right here. These two don't exactly touch. Here's a cross, but you don't get to cross. Well, yeah, it does. It's a little far away, though, but that could be. And here, this looks like it crosses. That could be. This whole area might be a hairpin. Multiple hairpins nearby. All right, that's your experiment. I know that's very iffy as to whether or not there's a hairpin there, but there are computer programs for this. Still, you know what? The best one is usually you looking at it and confirming it. Computer might give you some hints as to places to look, and then you need to go look at it. We won't use computer. We actually, I can give you a program that will look for hairpins, and they'll find them. They'll find them even when they're not there. That's the problem with the computers. You need to make it a little bit more rigid. But that's how to find the hairpin in the Terminator. You kind of know the region it's going to be in. You know it's going to probably be around wherever our polyadenylation signal is. It needs to be after or incorporate the polyadenylation signal in it. So because the polyadenylation signal needs to actually be on the actual sequence. So maybe we should do that. Maybe we should go back and find out exactly where that terminator was. I mean, the polyadenylation signal was, and that would give us a clue as to where we should start looking. It should be at the polyadenylation or later, all right, for the terminator. So yeah, let's go look at this sequence. And that's our random sequence. I wanted to look at our other FASTA, so I can open my program. Let me do that. Let me run this. Can I hit it? There we go. Okay. So I'm going to open that. Let's see, I have it here. C3, that one. All right, this is the same sequence. And of course, we're looking for polyadenylation, which is AAT, AAA. All right, and so it's one of these. This one is at 6,160. So it needs to be here or later. That's why I started at 6,000. And, you know, one of these, somewhere after that, down here, is going to be your terminator. Where exactly, we don't know. But you probably can start looking for it right here. it can include the polyadenylation signal. So the polyadenylation could be included in it. So I would start, if this is at 6.1, start at 6,000, go to 7,000, and where would 7,000 be? You could just take out everything, go to about 1,000 after it. I mean, it always could be further away. They can be quite a bit. So, go from about right here back up to your polyadenylation. Control C and Control V, make you a new fast day, and just look for that on a smaller sequence. That way you don't have to worry about all the gunk up around and searching around like we were doing. In fact, let's do that. I know it's taking up a lot of time, but making this a longer video, but I can just go Control V, and most programs will actually, by the way, read here, let's go a straight line fast day. If you end up with no, here, let me scroll all the way back to the beginning here. Alright, if you make a fast day like this with everything and hitting no carriage returns, actually it will most programs will read that. Not all, but most programs, and I'm pretty sure that Eugene will read this correctly. So I'm going to do this as a terminator region, or GPX1. Alright, I'm going to name it that. Save as, and we'll go, not example, we will rename that termination region GPX1, and there we go. Alright, so now we just got that region. Alright, and this region here as a fast day, and we can now go back to Eugene, and we can do a dot plot with that one. Let's go open it. It's right here, right here, this one. Compare it to itself. Alright. Go next. And search for inverted repeats. Hit this one. We'll start there. Alright, so now it's between, remember this is about 6,000, and this is a little bit before 6,000. This is a little bit after 7, I think. So just remember when you're translating back to the other one where this was. But now we've got the whole thing, and we know all this is the region we want to look at. So you don't have as much going on. You don't have to move around and worry about where you're at. So let's go to 6. All right, that's looking good up there. Go to 7. All right, let's take a look at this piece. All right, this piece right here, up in the corner in the 6,000 range. All right, let's go back down to, let's do 4. Go a little low. Not seeing a lot of crosses there. So go up to 5. Maybe not. So that might not have been the region we wanted, but we'll go back to 7, and I'll go to 80%. Way too busy. Don't. Just looking here, maybe there, going along this diagonal, think this is probably where we were. Crosses down here. Yeah. Sure enough, right there. Oh, a lot of them right here. This might have been the same place we were looking at before. So let's go down to 6. They stayed. Yes, yes, I like this. Okay, so I would have claimed this as the Terminator, this region in here. I see lots more out here, so they're getting too far away, though. They need to be, you know, within, say, this region here. But yeah, you could say that that's probably your Terminator right around here. So you would have to go find this sequence and back in the other one and say where it was and highlight it. But yeah, that works pretty well. So it was about 800 past the let's see, past the polyadenylation signal, somewhere in there. All right, I just wanted to show you that. That's how you find a terminator. All right, and how you use dot plot. This is the main way you would use dot plot. You could also dot plot's also good for finding splicing sites. Okay, that or finding, well, if you have the mRNA. All right, that's it. No homework due this week. I will just let's go. Actually, since we're here, I posted an announcement, and I want to go over it with you before I make you turn something in. So I won't make you do anything. Just work on this. Kind of have an idea of how this works. Maybe you've looked at it with your gene. The other thing you don't need to know how to do is find the area after your sequence. So you may not be able to do terminators. So I want to show you that. You just probably have the mRNA. You probably don't have the actually genomic sequence. So I'll have to show you how to do that. And I don't want to do that in a video. All right, so here I go. No new assignments due this week. All right, but hopefully you watched this one before we get to class. That's it.